When the new school year began, I was teaching grade 5 and grade 8 science. I decided to take up and explore the art of journaling in the science classroom. I had done extensive research on the topic, including articles such as Promoting Inquiry Through Science Reflective Journal Writing and reading How to Think Like Leonardo. Topics included mind mapping as a tool to enhance memory and senses, journaling to better discover and understand thoughts, and enhancing the interaction ability of my students to relate with one another. Gelb in his book outlined 7 steps to genius every day, and these became the mantra of our classroom, including curiosità, sensazione, and the connection of art and science and whole brain thinking, and the balance between logic and imagination. Initially, our observations began with the refinement of senses, especially sight, to enliven one's experience, and we focused on living in the moment and focusing on what they were observing, either in the classroom or out in the schoolyard and in nature. I took up reading this book, Mapping Inner Space, because mind mapping was a new topic to me. And the Science Notebooks book, Writing About Inquiry by Campbell and Fulton, helped me outline the first steps in developing the knowledge and skills students would need to take up this work as acting like an authentic scientist with a journal or notebook. The beginning. The first thing we took up sketching was an apple, and I sketched it with them. As you can see from this diagram, we outline what a scientist would have to record: subject, materials, procedures observed. The students asked questions, and we explored further. Here is a sample of a grade 5 student, which had me wondering if I was actually on the right track or if this was going to be a disaster. When I walked past his desk, he had drawn a sword and that little tiny diagram to the left of the screen. I asked him nicely, "Can you draw what you see?" And I reiterated Leonardo's principles we were focusing on, and he erased everything, and this is what he drew. When the students asked further what was the thing at the bottom of the apple, we talked about using magnifying glasses and how scientists would record that in their journals, and this is what he drew on the next page. Again, I was frustrated and wondering if I was doing the right thing with my science class. The following class, we sketched this plant, and I set it up under the document camera. When I walked past the student's desk, he had drawn what you see in the middle of the screen. When I asked him and guided him to have more detailed drawing, he scribbled on his page and wrote, "It's a plant." Again, I was frustrated and thought this was going to be a disaster. But I remembered I had read Making Classroom Assessment Work by Ann Davies, and in particular, there was a rubric in the back was actually dealing with science, setting criteria, and having the students reflect if they'd met or not met the criteria outlined. I also had read Making Thinking Visible. At the beginning of the next class, I had designed a rubric and discussed what setting criteria were and outlined the criteria for the plant drawing. I also guided them on and modeled how to perform peer-to-peer assessment and kind, actionable feed forward based on the criteria. The students went back to their desks and they worked in pairs. You can see the criteria is listed on the left side: met, not met, please notice, and to improve on for next time, which revealed interesting things about what my students valued in learning and where I needed to take them next. And you can see it was done in 2 different colors. There was a self-assessment and then a peer assessment. The following day in class, we took up sketching this leaf that was damaged because it intrigued them. I walked past the boy's desk and I was very nervous as to what I was going to see. And this is what I saw. We had discussed at the beginning of class on how to live in the moment and draw what you see as a scientist would in nature. Further, we took up how a scientist would label a scientific diagram using a ruler to the right-hand side, and we had to look up the parts to see that we were labeling them accurately. We did another self-reflection. This is not the one belonging to the students, and you can see that they didn't quite know how to articulate things when they always talked about things being pretty and neat. The following day we sketched this plant in color, so they moved to using colors. And this is what the grade 5 student came up with in his journal. I feel overall I applied the guiding principles of formative assessment for making teaching and learning visible. In particular, comparing achievement to clearly articulated criteria, and I used these sorts of rubrics through my course with these students. It supported both me and my students in the development of the metacognitive processes. Provided descriptive, specific, actionable feedback from students to teachers and teachers to students, and of course students to students. It encouraged my students to take increased responsibility for their learning and invited teachers to become students of their own learning and practice, and which of course is where I was at. Finally, it enabled students to use information gathered to guide adjustments to their own learning processes and develop new and deeper understanding as we extended this type of reflection into the programs of studies. It also helped my science teachers and my science team to analyze evidence of student learning independently and through PLC conversations so that I could adjust my instructional responses, and so could my colleagues.